All right, hello everybody. Mr. A here again with a new section in Algebra 2. Today we are in Section 3 of Chapter 2. So Section 2.3, we're going to talk about rate of change and slope today. So let's get started. First of all, our objectives. We want to be able to find the rate of change, number one, and number two, determine the slope of a line. Okay? And so right now you might be singing that little song, but all right, rate of change, first of all, is just a ratio that compares how much one quantity changes in regards to another. Okay, so in other words, more simply, it's just a fraction, basically. A ratio is just a fraction. And on the top, you're going to put how much y changed, and on the bottom, you're going to put how much x changed. Okay? So the change in y over the change in x. And you might, in one of your science classes, have come across where they've called it delta y over delta x. That's the same thing, just how much y changed compared to how much x changed. All right, let's look at an example. So first of all, we've got a table here with some data, and the time here in this column, these are all the x's. In the distance column here, these are the y's, so that's your x's and your y's. So we're going to just figure out how much it changed from the y's compared to the x's. So let's start out here with the y's. How much did it change when we went from 8 to 16? It went up by 8, right? So 8 is how much the y's changed. We'll put that on the top of our fraction there. Well, at the same time that this went from 8 to 16, how much did it change here? It went from 2 to 4, so it went up by 2. So it changed by 8 every time x changed by 2. So we could just simplify this or reduce it to 4 over 1, or in other words, 4 feet per minute, what we could say there. You know, miles per hour, miles per gallon, those are examples of rate of change. Okay, so in this case, 4 feet per minute. Now you might say, well, Mr. Anderson, what if you picked something else? What if you did the 16 to the 32? That changes by 16. Okay, changed by 16. Well, how much did the x change by there? It went from 4 to 8, so it went up by 4. Well, if we take that and we reduce it or simplify, you know what we're going to get? Same thing. And so we also, if we use those other pieces of data there, we get the same thing, 4 feet per minute. So that should work with anything in the table there. All right, slope. Slope is just the rate of change, but it's specifically when we graph something is when we talk about the slope, but it's really the same thing. Okay, so you may have heard of this phrase. I've got it written down here, rise over run. Rise over run. Well, this is just kind of another way to say the same stuff that I've been talking about already. M is for slope. So anytime you see M, that's going to be slope. Why M? Why not S? I don't know. M is slope. So it's rise over run. Well, what does rise mean? Okay, well, watch this. What did I just do? I rose. Okay, so rise is when you go up and down. Okay, that's the y's. And then the run, what happens if I turn? What did I just do there? Well, I know that was kind of silly, but I was running, okay, quote, unquote. I was going sideways. So when you run, you go sideways, that's like X. When you rise, that's up and down, that's Y, okay? So it's really the same thing, rise over run. And we've got a little formula here. M equals Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. Basically, all this is it gives you, the 2 points here. you've got your first x and your first y, your second x and your second y. It seems a little kind of confusing, but all this means is just a way to keep track of the x's and the y's, really. Okay, so we're just going to say here, this x in this one is your first x, this x here is your second x. You know, this is your first y, that's your second y. You're not going to square it or anything like that. It's just a way of keeping the x's kind of separate from each other, so you know which one's which and you don't get confused. All right, well, let's take a look and see how we could use this formula to find slope. All right, here's a couple of examples now. We've got 2 points on this first one. So now remember, our formula here is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, that's our formula. So what does this mean? We're going to take the second y and subtract the first y. Well, how do I know which one's the first one and which one's the second one? The answer is, it doesn't really matter. As long as you keep it the same through the whole problem, you're fine. Okay, so for this example, I'm going to say, what if this is x1 and that's y1, that's x2, that's y2. Okay, so let's use this. All right, what's the second y? Second y is -2. So I'm going to plug that in, -2 minus the first y. What's the first y? 4. So -2 minus 4 on the top. And then on the bottom, the second x is 1. And we're going to subtract the first x, -1. Now this is a little tricky, so watch out on this one. The formula says minus x sub 1, so we have to subtract whatever number is in here. So we're subtracting a -1. Sometimes people forget that second negative in there, but whenever you're subtracting a negative, it really becomes plus a positive. So what we really have here then is a -6 over 2, which would just simplify to -3. That's your slope. Or in other words, whenever you have, like, if somebody tells you that your slope is -3 here, it's the same thing as -3 over 1. So when you actually count it out on a graph, if they just tell you that your slope is -3, you're going to count it out as down 3 and then 1 to the right. Okay. Well, now you might be asking yourself right now, what happened if on my x1 and y1 over here, what if I ended up switching those around? What would have happened? Well, let's see. All right, so here now we've got slope. Now we're going to do, instead of y2 minus y1, what if we switch these around and we did y1 minus y2? So now I'm going to do 4 minus a -2 and then -1 minus 1. Well, minus a negative makes it plus a positive. So now we have 6 over -2. What does that simplify to? -3, same thing. So if you notice, on the top one we had a -6 over 2, and on the bottom one we had 6 over -2. Basically, just the negative changed places there. That's kind of what's going to happen. So as long as you keep going in, keep everything in order, you'll be fine. The only thing you do not want to do is don't switch in the middle. Like on the top, don't do y2 minus y1, and then flip, and on the bottom do x1 minus x2. If you change in the middle, that's where you're going to get in trouble. Okay, so just whatever point you pick with to be your first point, stay with that. And whatever is the second point, stay with that the whole way through. All right, let's look at the other example here. So again, here's our formula, y2 minus y1. All right, so what goes in here? On the top, y2, 7 minus a -3. And then 2 minus 9. So minus a negative makes it plus a positive, so this ends up being 10 over -7. Now we can't reduce that at all, and so we're just going to have to leave our slope there at -10/7, or 10 over -7. So whenever you can reduce a fraction, you're going to do it, but in this case we couldn't do that. We'll just leave it like it is, okay? All right, next. What if we are given a graph? All right, what if we're given a graph and we want to find the slope of the line? You could do the exact same thing that we just did, plug it into the formula if you wanted to and go, well, what's this point right here? Negative 1, 0, and this point is 1, 1. And then you could plug those points into your formula and figure it out. But to me, whenever I've got a graph, I'm just going to count it out. Okay? Remember what we talked about before? We said the slope is rise over run. Well, all I have to do is pick one point and count out what it takes to get to the other point. So if I'm going to start at this point right here, what's the rise? How far up do I have to go? Well, I have to go up 1. So the rise is 1. Once I've gone up 1, now what do I have to do? I have to go to the right, 1, 2. That's the run. So I have to rise by 1 and run 2 to the right to get to the other point. So the slope is 1/2. Now you might ask me, well, what if I did it the other way around? What if I went from this one to that one? Okay, well, let's see. If I'm going to start at this one, what do I have to do to get the other one? Well, first, how far up or down do I have to go? I have to go down 1. So this time, I have to go a -1 for the rise, and then I have to go to the left 1, 2, which is a -2 on the run. So now I have a -1 over -2. What happens whenever we divide a negative by a negative? It becomes a positive. So I end up with the same thing. So once again, just like in the formula, it doesn't matter which one you put first and second, as long as you keep it the same the whole way through. Here, it doesn't matter which one you start with, what point you start with, and which one you go to. It's going to give you the same slope either way. Okay, slope of 1/2. All right, how about this one? Let's count this one out. Okay, same thing here. Rise over run. So let's start with this one. What do I have to do? Up 1, 2. So 2 up, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the left, so that's a -9. So I've got -2/9. If I counted it the other way and started with this one over here on the left and counted down to the right, it would just be a -2 over a +9, which is the same thing. Okay, so either way, you're going to get the same slope. All right, couple of things here to finish up with. Remember, we did a couple of examples. One slope was positive and one was negative. Sometimes you might make a little mistake here or there, but if you know a couple of general things, you can maybe kind of double check yourself. And here's one of those things. If you have a line like I've got over here that's going up to the right, okay, we read from left to right. So for us, it's kind of easy to remember. It's going to go from left to right. And if we go from left to right and it's going up in any way, like here, that's going up a little bit, or if I had another line that was going up a lot, it doesn't matter what angle that's at. As long as it's going up to the right, it's positive. Okay? And how I remember that is you think, oh, if everything is positive, it's up and happy, right? Up and happy and positive. Okay? That's if it's going up to the right. What about if it's going down to the right? Again, from left to right and it's going down. If it goes down a little bit or if it goes down a lot, like this, anytime it's going down to the right, it's going to be negative. And you think, oh, if you are going down, you are very down and negative and depressed. Okay? So down to the right is negative, up to the right is positive. If you generally know, based on that, if you should have a positive or a negative slope, when you work it out, it kind of helps you make sure that you've got the right sign. You know, like if it was going down to the right and you ended up with a positive slope, you say, oh, something's wrong. I got to figure out what I did wrong. Or if it's going up, which should be a positive slope, and you got a negative slope, you must have done something wrong. Double check it. So just a couple of things that you can do to kind of double check yourself, make sure you got that right. And then last thing here, a couple of special situations. We're going to talk about these more as we go on. But if a line is vertical, which means it's straight up and down, it has what we call an undefined slope. What does that mean? Okay. Well, let's pick a couple of points on this line here and figure out what the slope is if we put the numbers in. Well, this is going to be what? -4, 0. That point right there. -4, 0. Let's pick another one here. Let's say we go to this point right here. That's negative 4, 2. Okay? Let's just plug it into our formula and see what happens. So I've got m equals, what's y2? 2, and then y1 is 0, so 2 minus 0. And then on the bottom I have negative 4 minus a negative 4, which is what? Plus positive. So I end up with 2 over 0. 0. What does that mean? I'll tell you what, if you got your calculator right now, take it out really quick, plug that into your calculator. 2 divided by 0. All right, you got it? You plug that in, it's going to say something along the lines of error, can't divide by 0. This is mathematically something that we cannot do. We cannot do 2 divided by 0. We just can't do that mathematically. We can't get a number for that. So that's why we have to call it undefined. So we say the slope is undefined. So that's the first thing that you need to be aware of, that whenever you have a line that goes straight up and down, the slope is undefined. We don't have a number for it, we just call it undefined. And again, we're going to talk about this a lot more later, but the equation of this graph, if you look at it go straight up and down, what would the equation be here? Well, look at the points that we got, negative 4, 0, negative 4, 2. If I pick some more here, I've got what, negative 4, 1 right here, negative 4, 3, negative 4, 4. X is always negative 4 on this line. And so what ends up happening is x equals negative 4 is the equation for that. Notice too as well, a lot of people get confused because the x-intercept goes horizontally, but when you have a line of x equals a number, it always goes up and down. It's opposite of what the x-axis is there. Okay, that's a little tricky, but we'll talk more about that later, but I just want to introduce you to that right now. And then the other thing is if we have a horizontal line. Okay, so another special situation, let's look at these points here. This point right here is 0, negative 2. So we have 0, negative 2. And then let's pick another one here. How about 2, negative 2? So here's 2 points on the line. Let's do the slope here. I've got negative 2 minus a negative 2. And then 2 minus 0. Minus a negative is really plus a positive. So this ends up being 0 over 2. What's 0 over 2? Again, if you want to, plug it into your calculator, divide it out. This time it's going to say 0. So when we have a horizontal line, it doesn't matter what 2 points we pick on that line, the top 2 numbers will always give me 0, whatever the bottom number is, and so we've got a slope of 0, always when it's horizontal. And again, look at those 2 points, negative 2 for y, negative 2 for y. If we pick 1, negative 2, 3, negative 2, 4, negative 2, y is always negative 2 on this line, and its equation will be y equals negative 2. And again, kind of the same thing as up here with the x. It's different. Y-axis goes up and down, but the equation of y equals whatever, in this case negative 2, is sideways. So it goes across y, not the same way as the y-intercept. Okay? Anyway, we'll talk about that stuff a little bit more. I just wanted to kind of get that out to you right now. But so we talked about rate of change, slope, using the slope formula to plug a couple of numbers in. And so that's what we talked about today. Thanks for joining me, and see you again next time when we work on Chapter 2, Section 4. We're going to start talking about writing equations more in that one. And so we'll see you then. Thanks. Bye.